Okay, we are here now in the VPC section. So under this VPC sections, we are going to cover up some of the topics related to all of the virtual private cloud. So that includes starting with the VPC basics, VPC peering, transit VPC and transit gateway, VPC endpoints, VPC endpoint policies, private link, and VPN. Then we have direct connect, and then we have on-premise redundant connections. So in this lecture, we would be beginning with VPC basics. So let's start. Okay, so now here this VPC and so I would assume that you know all the basics of the VPC that I'm going to go over right now. So I would assume here that is in the beginning. So here it's the first slide. So if anything is unclear, please investigate on your own. So a CIDR is a block of IP addresses and is defined as an IP address slash a number. And the number defines the IP range. So for this example, 192.168.0.0/26, so is equivalent to a range of 64 IP that start at 192.168.0.0 all the way to the 192.168.0.63. Okay. Then we have the CIDR block are going to be used everywhere on the AWS, and they will be used when you have security groups, route tables, VPC, subnets, etc. So knowing what a CIDR block is very important going into the exam. Obviously, a private IP is going to be an IP that's going to be only accessible within the private network, and there is a limited range of private IP that is defined by the norm defined by the. So now, so we have the range of like 10.0.0.0 all the way to the 10.255.255.255, which represents the CIDR block 10.0.0.0/8, which is when you have a big network. When you have a big network, you would utilize it. Then there is like the IP address 172.16.0.0 all the way to 172.31.255.255. So which represents the default AWS CIDR block. And finally, we have the smaller 190.192.168.0.0 all the way to 192.168.255.255. And when we present the CIDR, it goes up to 192.168.0.0/16. So this represents here the home networks, for example. So like for example could be the kind of things you have using your home router. So these are the only possible private IP you have. Anything else is going to be public IP. So this is all you need to know right now on the IP side. Next we have the VPC. So what is the VPC? What is a VPC? A VPC must be defined as a list of CIDR blocks and cannot be changed, and the VPC will present your virtual private cloud based on these CIDR blocks. So it's just CIDR. Its CIDR within your VPC must have a minimum of size of 28 and a maximum size of 16, which represent 65536 IP address, 65,536 IP addresses. The VPC is by definition private, so only private IP set or range are going to be allowed within your VPC. Next, a VPC is made of subnets. So this is within a VPC, and you define again a CIDR that's going to be a subset of the VPC CIDR. That's why it's called a subnet. All the instances within the subnet will get a private IP. Based on the CIDR you have defined for that subnet, and the first 4 IP and the last one is in every subnet are going to be reserved by AWS for networking subnet. So how many IP? There are the 5, 4, first 4 IP and the last one IP in every subnet for the AWS networking purposes. Okay. Then we have route tables. Route tables are used to control where the network traffic will be directed to, and they are associated with specific subnets. Specific subnets. So they are an idea that to say, okay, for going from one subnet to another, you need to use this route. So this is what the route tables are used for. The most specific routing rule is allowed, always followed, and so as long as the routing rule is going to be smaller, so then like slash number is going to be higher, so slash number /24, and then we have /0. So then this route will always be followed by default, and this is something we'll have a look at when we look at the VPC pairing. Okay, next we have Internet Gateway IZW to help connect our VPC to the internet. It's highly available and it will scale horizontally. The idea is that it will act as a NAT for instances that have a public IPv4 or public IPv6. So any instance that you linked your internet gateway will have internet connectivity, and this is how we define public subnets. So the public subnets are subnets that will have a route that will send 0.0.0.0/0. So that means all internet traffic to an internet gateway, and the instances must have a public IPv4 to talk to the internet. That's why they are called the public subnets and public instances. Whereas private subnets are accessing the internet through a NAT instance or a NAT gateway, and that NAT instance or the NAT gateway needs to be set up in a public subnet, and then the routes on the private subnet must be so that 0.0.0.0 routes all traffic to either your NAT instances or your NAT gateway. So this is the idea: internet gateway, public subnets, private subnets, NAT instance, NAT gateway, and you should know this already. Going forward, let's go a bit deeper into what a NAT instance. So NAT instance is, so it's an EC2 instance, okay, that you are going to deploy within a public subnet, and then, as I said, you need to update the routes in your private subnets to route to 0.0.0/0 all traffic directly into your NAT instance. The idea is that the traffic will be going through the NAT instance into the internet gateway and into the internet. It's not resilient to failure in such a case, and you have limited bandwidth based on the EC2 instance type you have chosen, but it's going to be a cheaper service. So in case in case your NAT instance fails, you need to manage failover yourself, and that could be quite complicated to set up. The alternative is to use a NAT gateway. So a NAT gateway is going to be a managed NAT solution by AWS, and the bandwidth will scale automatically, and you are going to pay per hour, and through the amount of the network that goes through the NAT gateway, it's going to be resilient to failure, but only within the single availability zone. So that means that if one of the underlying NAT instances in your NAT gateway fails, then AWS will know how to fail over to the other ones. But in case you want to have multi-availability zone, high availability, then you need to set up multiple NAT gateways in multiple availability zone. And then finally your NAT gateway will have an elastic IP, and so the external services will see the IP of the NAT gateway as the source. And I will explain this to you right now. So we have our VPC and our private subnets and our public subnet. So our private subnet will have a private EC2 instance that has a private IP, and we are trying to access a third-party website on the internet. So the idea is that we'll set up a NAT gateway or NAT instance in our public subnet, and we want the traffic to be redirected from the private subnet into the NAT gateway or the NAT instance, and then the NAT gateway and the NAT instance knows how to talk to the service through the public internet, obviously going through an internet gateway. So now, as I said, there is an elastic IP attached with your NAT gateway or NAT instance, and this elastic IP is what the third-party service will see the incoming request coming from. So if you are managing the third-party service and they are asking you which IP should I whitelist to let your application talk to me, then it should whitelist the elastic IP of your NAT gateway and you add your NAT instance. Hopefully that makes sense. Okay, next we have network ACLs, NACL or NACL. They are stateless firewalls are defined at the subnet level, and they will apply to all the instances within that subnet. And NACLs are always special because they allow for allow and deny rules. Stateless, that means that that any return that any return traffic must be explicitly allowed by the rules. So this is very helpful when you want to quickly and cheaply block a specific IP address. But they are complicated to use because they are stateless, and so you need to have both rules allowing traffic and allowing traffic out, allowing traffic in and allowing traffic out. Then we have security groups, and these ones are applied at the instance level, not the subnet level, and they only allow for allow rules. Okay, and they don't have any deny rules. A stateful means that the return traffic is automatically allowed regardless of what the rule says. So that means if your instance is sending traffic to a third-party service, you have the guarantee that it will be able to come back through the security group. Obviously, if the network ACL allows it as well, the traffic going into your instance, for example, if you are HTTP server is allowed to go back out to the service that request itself from you. Okay, so security groups are very special because they also allow you to reference other security groups in the same region, even with a paired VPC or with like the cross accounts, even with cross accounts. Okay, now then we have next how about logging, like the VPC Flow Logs. So we have VPC Flow Logs, and they allow you to log the internet traffic going through your VPC, and it can have three kind of VPC flow logs. The first one, it can be defined at the VPC level, the second one at the subnet level, and third one is at the ENI level, Elastic Network Interface, which is a virtual network card attached usually to your EC2 instances. And they're very helpful when you want to understand why your traffic is not going the way it's wanted. So to capture denied internet traffic, this will show you why it is failed and where it is failed, and then these VPC flow logs can be sent to CloudWatch Logs or Amazon S3, which is very helpful. So if you want to see, for example, an increase in traffic onto your infrastructure, and what would probably lead to you are thinking that you are under attack. So like next we have the Bastion host, and they allow you to do SSS into private EC2 instances by using a Bastion host, which is a public EC2 instance in the public subnet. So it's a 2-hop SSH, and in case you are using Bastion host, you must manage the instances yourself. There's no managed Bastion host by AWS. That means you need to manage the failover and the recovery and the security of this Bastion host. Okay, so but the new way now to avoid this Bastion host is to use, as you know, SSM session manager, because we can remote control our instances that have the SSM agent running on them without using SSH, which is a better security model. So we would use the SSM rather than Bastion host. Okay, and next we have IPv6. So IPv6. So I'll try to explain you in short, but all the IPv6 addresses are going to be public, and the reason why IPv6 addresses were included and inserted and created is that we are running out of IPv4 addresses. So IPv4 addresses are total of 4.3 billion, but currently we are about to run out, and so we have invented IPv6 to have public addresses, and we have about a total of 3.4 times 10 to the power 38 addresses, so which is a huge number. Okay, so here is an example of a CIDR for an IPv6. It looks like a lot more complicated than IPv4. You are now expecting to know how this works exactly. So this CIDR block you are saying /56, it's really bit complicated. You are not understanding what exactly the range is. So the address, so on the left hand side there is an IPv6 On the so there is an IPv6, and on the right hand side there is a subnet mask. So the addresses are seemingly random, and the idea is that because there's so many addresses online, they can be that can be IPv6, then no attacker can scan them all. It will take forever, and so the idea is that if you are using an IPv6 for your instance, it's somewhat going to be protected from attacks as long as people can't guess its IP address. So this is quite a beautiful thing, and the internet is slowly transitioning from IPv4 to IPv6. Now your VPC does have support for IPv6. How does it work then? So we can create IPv6 CIDR for your VPC like the one I showed you above, and then you can use Internet Gateway, which, as I said, supports IPv6 traffic. So you can make this work. Well, in your public subnet, you are going to create an instance with IPv6 support, and that IPv6 will correspond to the CIDR that has been assigned to your IPv6, and then you have to create a route table entry for ::/0, which is the shorthand for of IPv6. Also for like IPv4, it was all traffic like 0.0.0.0/0, and for the IPv6 it's ::/0. So which represents all IPv6, and so we are saying any traffic to an IPv6 is going to be sent to the internet gateway, which remember, like, it supports IPv6, and so for your instances in private subnet, they are still private, so they still don't have an IPv4, and they still don't have even an IPv6, but they may want to target external services that are only reachable using IPv6, in which case we have to create something very similar to NAT gateway, but for IPv6 is called the egress only internet gateway. So in the public subnets, and this has support only for the IPv6, and then we add a route table entry from the private subnet for ::/0. So all IPv6 directly into egress only internet gateway, and this way our instances in our private subnet will have IPv6 support to reach to external services, and that's it. So all of this should be something you simply know for the VPC. That is why I call it basics, and then in the next lecture we are going to view a lot more details on a few aspects of VPC, like VPC peering and VPC gateway, so that are going to be critical going into the exam. So that's it. We'll see you in the next lecture.